Raturi. Her talk is on cultivating trust in technology-mediated sustainable agriculture research. And please begin.
Hi, so hopefully you should all be able to see my screen right now. Is that correct, Aaron?
It's working great.
Perfect,
Yes.
Great. So good morning, folks. My name is Anita Raturi, and I am an assistant professor at Purdue University in the Department of Ag and Biological Engineering, where I run the Agricultural Informatics Lab. And so today I'll be sharing some of the work that I've been doing with a pretty large group of collaborators from USDA, NC State, UMD, and a variety of other institutions through the Precision Sustainable Ag Collaborative, where we've been really trying to think about how to cultivate trust in technology-mediated sustainable ag research. So our desire is to manage agricultural complexity at scale and transition to more sustainable ag practices. And this has inevitably brought us to consider the design of tech that is trying to overcome a range of obstacles, right? So we need things to handle in-field spatial variability. And for that, we've been trying to integrate sensing across scales. You know, for trying to be able to identify weed and pests, we often use machine learning. And so this growth of big data in sustainable agriculture requires the application of data science for wrangling complex agricultural data, as well as, you know, our interest in integrating research and practice has driven us to the development of farmer-facing decision support tools. So I just wanted to start at least with some of this broad context of some of the obstacles and promises that we find we face within sustainable agriculture. So in 2019, we formed the Precision Sustainable Ag Collaborative with funding from a $10 million SASCAP grant that's headed out by Chris Weaver-Corton in NC State and Stephen Mirsky at USDA ARS to try and address some of these grant challenges. So our mission in the short is to be able to increase productivity, to conserve natural resources and reduce our agroecological footprint through the increased and improved use of cover crops. We want to actually be able to integrate knowledge-intensive sustainable ag practices into a precision management framework. And this requires a connection of farms, of data, tools, and people for optimal real-time decision-making. What we want is to be able to have people make the kinds of decisions that they're interested in making when they need to, and with the types of data that they need to be able to make it in that moment and in that place. So we're a network of about 40 organizations from 33 states conducting a range of coordinated research, education, and extension projects. Some of these, like the On-Farm project, which is a pretty big part of our group, began several years ago through previous grant funding, and other projects are still in their infancy as we try to begin to explore the promise of big data and improving our understanding of cover crops and improving precision in our practice of sustainable ag. So what ends up happening is this sets the scene for a complex trust landscape with a variety of different data stakeholders for different data sets. We have varying data sharing needs and usage constraints. We have different levels of privacy required for different data sets and multi-stakeholder ownership of data. So what we require was coherent mechanisms to thinking about how to mediate trust in our complex network of people, values, and objectives, as well as their associated data, models, tools, and other information products. This means that first we must be trusted with data. And so when thinking about our trust framework, we think of it in these two parts. First, being trusted with data, and the second being trusted in the process. And so because a lot of our work involves collection of data on farms throughout the country, we face the challenge of needing to protect farmer data while still making valuable data available to drive research and innovation. Earlier, Jim mentioned that there's a growing interest in public-private partnerships, and this is exactly one of the challenges that we're grappling with, where we would like to be able to work with a variety of stakeholders, but we want to make sure that we are protecting both the privacy and the agency of the people that we care deeply about. And so this means that a lot of the technologies that we design need to be privacy preserving and make sure that people are able to have situational control over their data and feel comfortable being able to share their data with us. In that second space, we also need to be trusted with process. And so we aim to practice transparency in our use of data through showing our work, right? So this is in the form of open source tools, in the form of stakeholder inclusion, and providing feedback. So real-time farmer feedback is something that we place a high priority on, and I'll share with you a couple of examples a little later. So we also bear the responsibility of being accountable to our research partners. And this includes farmers as well as our project stakeholders like funders and other researchers. And so today I'm hoping to show you a little bit of what we're doing that brings these 4 pieces together. And so I won't go through each in turn, but hopefully some of the examples that I will share with you will give you a sense of what we're doing. And ideally, when you eventually read our paper, you'll be able to see some detailed use cases of how this is all happening in action. So my co-authors and I form the privacy committee within the Precision Sustainable Ag Collaborative. So we're a group that's dedicated to articulating a trust framework in consultation with the full group. So this will culminate in a collaboration agreement that basically contains guidelines for how to manage data privacy, how to manage data agency, as well as how to ensure that we are accountable and responsible and transparent in the process itself. So each of the PSA project teams, again, we're a coordinated network of projects, right? So each of those PSA project teams, once they've come to agreement around things like research protocols and activities, are also tasked with thinking through the constraints that need to be placed on data collection, management, and usage. From here, these rules of engagement are then baked into the technologies by the different tech teams. And so this means that the tech teams are responsible for ensuring that our framework is both technically feasible, as well as that our technology itself supports the different things that we're trying to claim that we're doing within our trust framework. So a quick example would be, right now the social science team is currently working with the tech team to ensure that IRB protections, for instance, are respected when any human subjects data that's personally identifiable information about our farmers is collected, right? So we not only have PII information like that, but we also have a variety of agronomic information. And as I show you what our data landscape looks like, you'll see that we're juggling a couple of different things, and that makes the data flow technology team's job in particular quite challenging. But I think they've proven to be up to the task in a lot of the things that we will be showing with you today. So the tech team is responsible for implementing the data management solution that adheres to these rules. And then at the end of the day, they're also responsible for making sure that our collaboration agreement is updated and is constantly in sync with whatever we're doing on the ground. And so in this sense, what we end up with is technology serving as a mediator of trust. Technology serving as a mediator of trust, we've already agreed upon these rules through our social infrastructure, through conversation and collaboration within the PSA collaborative. So I'll describe this concept of trust mediation through a few examples in our data lifecycle. First, we collect research data on various research stations as well as on farms throughout the United States. These data then flow into a range of permission databases. They're stored in a variety of ways, and we have a couple of different data exploration tools that folks are still working on. Finally, we use these data in our development of cover crop models and tools, and ultimately, our work is intended to inform the extension, education, and actual practice of sustainable agriculture. So, what does this look like? In actuality, the PSA project is a collection of interconnected research and development activities happening across the nation. So we first have these R&D activities that are happening at different university and government research sites. We have a couple of alpha technology projects. These are basically collaborations between ag and tech researchers where we're exploring the tech frontiers to be able to meet specific cover cropping goals or research goals. So a really great example of this is sort of hot off the presses, really great work that's come out of NC State, led up by Paula Ramos-Giraldo. And this is the StressCam project, where folks have been developing a camera and machine learning system to be able to detect drought stress in cash crops. So once this technology matures, we're hoping to then be able to deploy it on farm. So concurrently, we also have these 2 major controlled experiments being conducted by researchers throughout the PSA network. And we're collecting a variety of different data, and there the focus really is on, road testing the research questions, trying to make sure that in those controlled environments we have a really good sense of what's needed, and that also gives our tech teams the space to start to develop some more alpha technologies to be able to try and automate some of those not very exciting data collection activities that we want to be able to automate using a variety of tools. And so from here, we have a variety of different on-farm research protocols. So when a research protocol matures enough, they are first beta tested on a small group of farms that we partner with, and then they ultimately move into the larger on-farm project. And so our most mature technology, which is just a really quick example, is a real-time in-field soil sensing system that was developed a collaboration between USDA ARS, UMD, NC State, and a private tech company who's actually now manufacturing the system. So here there's a sensing system that's deployed on farms throughout the PSA network. Data is streamed over cellular and it's served back up for both our researchers as well as our farm partners to be able to use.
Anita, that was that noise that was on the phone there. It was your 5-minute warning.
I'm getting there. Thank you. So by putting technology through its paces on research stations, we work out the bugs, we build out the data flow to preserve privacy, and we empower data stakeholders to be able to have a process that is both transparent and accountable. And ideally, and hopefully, this is how we begin to cultivate trust in what we are doing with a variety of different data. So data that's collected, and I want to just maybe touch briefly on how that data flows from there on out. Data collected in the on-farm project flows into a permission database that is accessible by different teams, depending on whether they're IRB approved or whether they actually work with that particular farm. And so there are a variety of guidelines that determine who has access to what, and you can see some work in here. Orally from NC State has been working really hard on making sure that this database is something that is actually accessible by the full team, and we're still working out some of the sort of rules and regulations of how we want to interact, but now there's a tech dashboard developed by Rohit also at NC State that will now at least allow for there to be a human readable interface to the data, as well as a machine readable mechanism through the database itself. And so from here, we also have a farmer dashboard. This is a project that's headed up by Brian Davis out of UMD and ARS. And this is a really critical piece of our work. This dashboard provides farmers with as real-time as possible data that is collected on their fields. And so this allows us to be able to actually engage them in the research process, so they are also then able to reflect on their cover crop performance. So now that we have the fundamental infrastructure, so that's the stuff that you're seeing under PSA members for data collection and flow in place, we're beginning to think about how to make these data accessible to the public, as well as the potential for ag and tech research partners in both the public and private sector. This has been extra motivation for us to try to think about what the guidelines for broader data sharing are, that once again would be mediated by some of the technologies that I've described to you that we build and both use. So using these data, we're also refining, designing, and developing a suite of cover crop models and decision support tools. So I just wanted to give you just a little bit of a glimpse as to how we're using the data internally, to also then give you a little bit of a sense of how others might too. You know, some of the tools that we're working on, so this is one that's actually currently going to be in beta mode this fall, is a cover crop selector tool, but the ones that are actually using this on-farm data and some of this more interesting or intricate data that I've been sharing with you today would include things like the water infiltration model that's being built out of in collaboration with a couple of different researchers. It's a nitrogen availability calculator that we'll be working on, as well as an integrated weed management tool in the pipeline. And so we have a couple of really interesting things, I think, in the pipeline, and I hope that you will be as excited as I am to learn more about what we're doing. So, you know, our own use of the data is basically a test case for collaboration with a range of partners, because we're basically trying to see if our own data sharing guidelines work within before we think about how they're going to work outside of us. So we view trust as a work in progress. We aim to uphold two pillars of trust in our work. First, we aim to be trusted with the data, and we do this through an implementation of privacy preserving technologies, as well as making sure that our tools support data stakeholder agencies, so making it clear who owns which data and how that data is going to then flow out. Second, we aim to cultivate trust in the process through our practice of transparency and by engaging in responsible data sharing practices, as will be codified in our collaboration agreement. We cultivate trust through both social and technical infrastructure. So our teams codify rules for engagement in agricultural data, and you can learn more about this in our upcoming paper. And then our technology teams actually make sure that the trust framework is upheld in the things that we actually build and design. At the end of the day, technology can only serve as a mediator of trust if people already trust each other. And so in that sense, I argue anyway, that there is no such thing as trust in a trustless society, and that we need to actually always have those social agreements and discussions before our technology can then be able to support what we're looking for. So, you know, cultivating trust, much like the development of protocols and research technologies to support sustainable agriculture, is an ongoing process that underpins large-scale collaborative research. And I hope that today I've at least been able to give you a sense of how we're cultivating trust within our collaborative through technology. And with that, I'd like to thank my collaborators in the PSA Privacy Committee, as well as the larger group on all of the different project and research teams for their contributions to this work over the last few months. And I look forward to sharing our outputs with you guys in the years to come. So thank you for your time today, and I look forward to some questions.
David, do we have any questions?
There are no questions submitted right now.
Okay, well, we'll give everybody 1 minute to maybe type it in the chat window. I'm sorry if you covered it in your talk, but what's the funding behind the projects?
The most recent source of funding is a SASCAP grant that we recently got. So that was last year. But a lot of the projects that are a little bit mature, so like the water sensor project, were previously funded, again, through NC State with a water cap grant, for instance. And so we've had a variety of grants that have helped at least kickstart the entire process. And now we're looking into a variety of public-private partnerships moving forward, hence our complicated data sharing landscape.
Excellent. David says there's 2 questions. So David, why don't you go ahead and ask the questions?
All right. One question is, I'd like to read more. Do you have a representative publication about the project?
That is a great question. We have been running really fast trying to build a tech and make sure that everything's going for this field season. As I speak, there are 3 publications in progress that should be coming out this year. For now, we have the precisionsustainableag.org website, which you can at least keep a tab on. Again, it's just a landing page, so I'm afraid it's not the most glamorous, but at least it should give you a place to go look for when we actually have some of these publications out. So I know that one of the things as part of this workshop is we are submitting a paper on what I just shared with you today as part of a special issue for agronomy, if I'm correct, Aaron. And so that will be at least one of the first pieces that you'll be able to read coming out. So soon.
Okay, great. And can you tell more about the tech team? Where are they situated? Are they students? Are they private, etc.?
They are, they are everywhere and from all of the above. So we have a couple of different tech teams. We have a remote sensing team that includes a couple of technology companies, university researchers, government researchers, as well as folks from a couple of nonprofits or non-governmental agencies. I always forget which ones they're bucketed under. We have a modeling and decision support tools team. Again, the same sort of mix of people. And then we also have a data flow team, which is responsible primarily for the on-farm data flow. And so these are at least the 3 that are right now the most active, because those are the spaces where we have really big things going on. And I think the makeup of the team itself is both, we have faculty, we have students, we have postdocs, we have interns and also technicians who are also making sure that our work is grounded in, what's actually reasonable to do in farm. I think that's been a really big push to make sure that all of our protocols, as I want to quote Chris here, he says all of our protocols need to be light and tight so that somebody can actually take that piece of technology out into the field and actually use it and not spend forever troubleshooting.
Can you talk about how to join the network? How might somebody join the network?
Yeah, I would recommend that you reach out via email and you can send it to me. I think I had my email address in the slides, but if you want a slightly more direct pipeline into people who are on the management side of things, I would recommend that you reach out to Stephen Mirsky or Chris Reber-Horton, and I'm happy to share their email addresses with you as well so that you can learn more about sort of the logistics of that.
Okay.
I think we have time for one more question.
All right. Do you have any comments on data sharing and trust across actors with different levels of control over the data collection and analysis?
Okay, so let me see if I can unpack that. So we do already have a variety of actors with different levels of control. So We have farmers, for instance, who are mostly just allowing us to collect data on their farms. We have researchers who are trying to use those in a variety of different ways. We have folks who are trying to use this data internally within our network, which I think is a little less messy right now, but then we're also trying to think about, how can we partner with a tech researcher who's not necessarily part of our group just yet to be able to, develop machine learning models. And so those are sort of some of the things that we're currently grappling with. And so one of the ways in which we're trying to do that is by first codifying the rules of engagement in the collaboration agreement. So I hate to punt the question a little bit, but that's sort of currently under discussion, is we're trying to figure out what the best way of practically managing that is. I think one of the things that keeps coming up during our privacy committee meetings is that we can write whatever rules we want, we can follow best practices, but a lot of the guidelines that we found require a lot of that human work. And we also want to be able to make sure that some of that trust is something that we can have the technology mediate. And so trying to think about which pieces of data sharing, can we just have an API that is simply, there's a token that you use, and because you've already agreed that you're allowed to use this particular data, you can use, that specific API to subset the data. And so we're just sort of trying to think about what all the different technological options we have are, and what the different stakeholders within our network need from a privacy and agency perspective, and then try to do some mapping from there to be able to make this all a reality.
All right, thank you very much, Ankita.
Thank you.
Yep, sorry, just jumping in, we're moving along.